Okay, yesterday we learned about four special types of angles. They were corresponding angles, alternate interior angles, alternate exterior angles, and consecutive angles. So we're going to learn that there's a special situation that comes up when you have parallel lines. Let's find out what that is. So let's get started. This is lesson 3.2. Use parallel lines and transversals. So, what's the deal? Okay, so students will be able to determine the relationships between the four angle pairs when two lines are parallel. How are the corresponding angles and alternate interior angles related for two parallel lines and a transversal? Now, I'll just mention that we will also talk about the vertical angles as well, and we've already had that in chapter 2. Before we go much further, let me go ahead and remind you what vertical angles are, and I should also remind you what a linear pair is. Those are ideas that come up in this lesson as well. So let me switch to my pen here. So vertical angles, when you have crisscrossing angles, angles 1 and 2 are vertical angles. And what we found out from chapter 2 was that vertical angles are always congruent. Okay? Well, now let me just talk about a linear pair. If you have a linear pair, let's have a couple angles in it, 1 and 2 here. Remember, there's a line involved whenever you have a linear pair. We also learned from chapter 2 that linear pairs are always supplementary. So it means these two angles must add up to be 180 degrees. Okay? So in other words, if you knew that this was 40 degrees, you could calculate this one real quick. It would have to be 140 because the two angles together would have to add up to be 180. So there you have it. We will use these two ideas in today's lesson. So I thought it would be a good idea to review that before we go much further. Alright, so let's continue. So there's four scenarios that come up. If you have two parallel lines cut by a transversal, it means that the corresponding angles are going to be congruent. And it means that the alternate interior angles are going to be congruent. And it means that the alternate exterior angles are going to be congruent. And lastly, it means the same side or consecutive interior angles are supplementary. Okay? Once again, that means that they add up to be 180 degrees. Alright? So these three are very similar. They have the same conclusion. Congruent, congruent, congruent. So this is the only one that's a little bit different. It's an oddball, so to speak. These type of angles will be supplementary. Well, let's try some examples, and hopefully this will make more sense to you. So we'll have several problems on our assignment, our study guide, and homework as well, where we're given one of the angles and we have to find all the other angles. Well, there's various ways to do this. For example, we just learned that corresponding angles are congruent if you have parallel lines, and there's the parallel line symbol. I want you to realize that this is only true when we have parallel lines. If you have a transversal, there's a transversal because there's the two intersection points, you don't normally have these special scenarios where there's a whole bunch of angles congruent. But we do have it when we have parallel lines. So we need this first. Okay, we need to know that we have parallel lines first. Once we have parallel lines, then we have all those four scenarios that can happen. Well, so one of those scenarios was that the corresponding angles are congruent. Well, so that means that this angle is congruent to this angle up here, which means it's 55 degrees. Well, how can we find angle 1? Well, there's our linear pair. So there's our linear pair, and we just found out that linear pairs are always supplementary. And so these two angles have to add up to be 180. So what what number do you add to 55? Well, it looks like to me it would be 125. So this angle is 125. It's getting a little bit messy now. So 125 degrees, that's this one. Now, we also have the vertical angle idea. Now this angle over here, they have to be congruent, so this angle over here is 125. Now I might add that we could have found out these two angles a very similar, a different way. We just found out one of the four postulates that we read about on the previous slide was that consecutive interior angles are supplementary. So what that means is that these two angles that are on the same side must add up to be 180. Sure. And so this one's 55 degrees, as we already said. This angle must add up to be 180 along with this angle, so that means this one's 125. So that was another way we could have gotten it. So what else? Let's see, we need to figure out these other angles. Well, if you notice, this angle 3 is a vertical angle. It's also an alternating interior angle. Now let me just show you something about alternating interior angles. Alternating interior angles always make a zigzag pattern. You see like this Z here? It always makes a zigzag pattern. This zigzag, I call it a zigzag pattern. And the zigzag pattern means that they're congruent. So these two angles are congruent. And so that means that angle 3 is 55 degrees. Alright, well you'll notice the zigzag pattern, there's another zigzag pattern. It's this one kind of here. There's another zigzag. And so these two angles are congruent. Okay? Because they're the alternating interior angles. So that means this angle 5 is 125 degrees. Okay? So what did we do? Are we finding them all? We found this one earlier. We found that was 125 degrees. And now what do we have? This is a vertical angle. Okay, this opposite side over here, that means vertical angles are congruent. Those two are congruent. But it's also a corresponding angle. It's in the same position. Notice on this group of angles up here, it's on the bottom right side. Well, the corresponding angle that's on the bottom right side is this one. We just found out that corresponding angle is congruent. We also know that vertical angles are congruent. So either way, we find out that this angle is 125 degrees. And we have corresponding angles over here. It's on the bottom left side, right? This is the bottom left. This group up here, this is the bottom left. So those are corresponding angles. So this angle here must be 55 degrees. So it turns out we can figure out, if we know just one of the angles, we can find out all the other 7 angles. And it turns out it's either going to be 55 or 125 degrees in this case. There's only two different measures, and that covers all the 7 other angles. And but that only happens, once again, if you have parallel lines. So always make sure we have parallel lines first. Just want you to realize that if you don't have parallel lines, we can't say that anymore. Okay? In this case, we have a transversal, but we cannot say that this angle is congruent to this one. That would be false. Why? Because in this case, these lines are not parallel. As you can see, they would intersect right here. You see? So keep in mind, these 4 theorems, or these 4 postulates that we read about, they're only true if you have parallel lines. Okay, so let's go ahead and have some more fun. Maybe you'd like to try it. Uh-oh, we have some algebra now. Well, the first thing when you're doing these problems is you want to identify what kind of angles they are, first of all, and then you want to identify which one of the 4 postulates is the one that I'm interested in following. Like for example, there's a transversal right here. There's one intersection point here, one here. And this angle, if I look at this group up here, it's on the right side and it's on top. Okay, I think it's on the right side top. Well, this is also on the right side and top. So it turns out that these are corresponding angles. Corresponding angles. And if we go back to the previous slides, the corresponding angles we found out are going to be congruent. Well, that means this angle here is congruent to this angle here. Well, what it means then is that I can get an equation. If they're congruent, it means they have the same measure. So I simply say, well, 135 must be equal to x minus 30. And now to solve for x, I'm just going to add 30 on this side, add 30 over here, and hopefully you can easily get the answer here that x is equal to 165. Bam. Are we good or what? Okay, so sometimes you'll have little algebra problems to do as well. Let's do some guided practice. Here's an opportunity for you to try some problems for me. Maybe we could have a few volunteers. Let's see. Alright, so here's our diagram. It's a little blurry here, sorry about that. But what we're told is that the measure of angle 3, that's this one down here, is 68 degrees. And angle 8 is 2x plus 4. Now you'll notice on this particular example, 3 and 8 are not one of the special 4 angles. Why? Well, let's go through them one by one. Are they corresponding? Well, let's check. Angle 3 is on the left side of this. Well, there's this transversal coming through here, and there's a group of angles here. And it's on the left side of this line here, and it's on the bottom left, right? Well, angle 7 would be the bottom left. So what we could say is that this angle is congruent to this one, but it's not congruent to angle 8. Okay, so how about the corresponding angles? Okay, so we tried corresponding angles, and 3 and 8 are not corresponding, so that's that. How about alternate interior? Well, first of all, these two angles are not interior, they're exterior. So this portion here would be the part that's between the two lines, and the part that's between the two lines is what we call the interior angles. So these are not alternate interior angles. Now it turns out that these angles are exterior. Okay, they are both exterior angles because they're on the outside. However, this is an exterior angle and that's an exterior angle, but remember they're not alternating exterior angles because they'd have to flip sides, and both 3 and 8 are on the same side. In this case they're on the bottom half of this line here, so they're not alternating exterior angles. Okay, are they on the same side? Well, they are on the same side, but they're not consecutive. They're not, I like to call them same side interior. Same side interior. Remember that? That's what I would prefer to say. Interior. So the same side interior ones would actually be angles 4 and 7. You see, as you go through this way, alright, as you go around and around like that, these are consecutive. You go bam, there's one angle, bam, over here there's the other angle. So these two are the ones that are consecutive, and if that were the case, we'd say that they add up to be 180 degrees. Okay, so what we've determined is that angles 3 and 8 are none of the special 4. So how do you solve this problem then? Well, the bottom line is we have to do something first. You see, we know that this one's 68 degrees. Alright, we know that this one over here is 2x plus 4. So it turns out if I could find out angle 4, then angles 4 and 8 would be corresponding, and then they would be congruent. You see? So my plan to solve this problem is to figure out what angle 4 is, and I can do that because I have a linear pair, and I've learned that linear pairs, these two angles here, form a linear pair, and I learned from chapter 2 that linear pairs are supplementary. So I can start out by finding angle 4. So if I take 180 and I simply subtract 68, I get 112 degrees. Okay, well, so that means this angle over here is 112 degrees. And now I just found out that these two angles are congruent. Okay, so then what I can say is I can make up an equation. 112 must be equal to 2x plus 4. And the reason why I know this is because they're congruent. They're corresponding angles. They're both on the right side on the bottom, right side on the bottom. And so now I just need to do some basic algebra. I'm going to subtract 4 here, subtract 4 here. I get 2x is equal to 108. Okay, and then divide by 2 here and divide by 2 here, I get 54 is equal to x. So there's another algebra problem. It's a little bit harder than the previous one because I had to find this angle first before I could find out the value of x. Now again, all of these rules that we're doing, they only work if you have parallel lines. So keep in mind you have to have these parallel symbols in there. If those weren't in there, we could not use any of those postulates that we read about. Okay, so we finished that problem. Well, now let's try a proof. We can prove a lot of these. Now, if we go back, let me just go back to the theorems. Remember, a postulate we don't need to prove. So I always know that the corresponding angles are congruent. And I'm going to use that fact. I'm going to use this fact right here. I know that the corresponding angles are congruent. I'm allowed to say that. And I also know from chapter 2, anytime I want, I can say vertical angles are congruent. Vertical angles are congruent. And I can use that theorem because we proved it back in chapter 2. In fact, we had a test on that. Hopefully you remember that. So we can use those ideas, and we can also use the linear pair idea if we want. Those are all tools that we can use to prove these three theorems. So now let's go fast forward back to that problem where we're going to do a proof. Let's keep going. We did that one. This one here. There's our guided practice we did. We just did that. And now let's try this proof. Okay, so we have in this particular problem, whoops, went to the wrong, back up there. What did I do? I wanted to do that. Okay, so, oh, that makes me mad. Alright, that's my old, okay, that looks better. Phew. Okay, so we have a proof here. And let's take a look. We have parallel lines. Okay, that's the given statement. And we want to prove that angles 1 and 2 are congruent. 1 and 2. So what we want to do is prove that alternate interior angles are congruent. Okay, so let's see how this works. Now, the first thing I notice is that I have some corresponding angles, and that was a postulate. So, like I said, we could use that. You see, angle 1 is going to be congruent to angle 3, and so the reason why I can state that is because they're corresponding angles, and that was a postulate. So let's do that right now. Angle 1 is congruent to angle 3, and that was we call it by its title, basically. Corresponding angles are congruent, and that was a postulate. Okay, that's the one that we're allowed to use. Corresponding angles are always congruent, but I also said that 3 is congruent to angle 2 because they're vertical angles. And remember, we learned back in chapter 2 that vertical angles are congruent. So I could then say angle 2 is congruent to angle 3. Well, maybe I should just do this. I'm just going to back that up just a little bit and rewrite it the other way around, because I want you to recognize something. Angle 3 is congruent to angle 2. Let's write it like that. Now, do you recognize this setup? We've seen it many times. I can now say, based on this setup right here, which you should all recognize, that's the transitivity idea, right? So I'm going to say angle 1 is congruent to angle 2. Oh, by the way, we need the reason here. The reason for this was vertical angles are congruent. And that one is a theorem, so we'll just call it TH for theorem, POST for postulate. And then the final line here, we say angle 1. By the way, we're done now. Remember, whenever you're doing proofs and you get the final line will be the proved line, these will always be the same, and that's the way you know you're done. So line 4, we're going to call it the transitivity property. And like I said, we use that an awful lot, and as you see in this chapter 3, we're starting to use it, and we will continue to use vertical angles and transitivity often in chapters 3 and 4. So there you have it. We have a proof. So I'll just say that we use this one a lot. We use the corresponding angle ones a lot. And so if you do a proof on your assignment, look over this example. It's very similar to the ones that you'll do on your assignment as well. So here we have the little summary of what we learned about. How are the corresponding angles, alternate interior angles, parallel? Well, they are congruent. So we should add also that the final idea had to do with that consecutive angles are supplementary. So, well, pretty easy assignment, but make sure you master this. The main thing, you have to train your eyes to visually see these types of angles as you look at the diagrams, and keep in mind the diagrams will get more complicated on the assignment, so there often might be more than one transversal. So that being said, good luck on it, and we'll see you tomorrow.